Students, welcome to another video of Vedantu Karnataka. This is Catherine, your physics master teacher. Quickly, let me know if I'm audible and visible. How are your midterm preparations going? All of you ready to score full marks? Yes? Students, welcome to another video. The audio is clear. Okay. Just a second. Okay. Ready? Ready to solve a practice paper? Hi Yasin, hi Attitude Boy, hi Gaming, hi Hemanand. Okay, yeah. Welcome to the lesson. Are you all writing MVSAT? Quick reminder, please don't miss out MVSAT. I think all of you have already registered. Yeah, it's a wonderful opportunity, students. I don't want any of my loving students to miss that chance. Okay, that's why I keep on reminding you. Yeah, make sure you write the exam. Don't miss the dates. Okay. Provide physics most important 3 marks question notes, ma'am. Yes, I will. Okay, I'm going to do a marathon maybe day after tomorrow on the channel where all 3, 2, 5, everything will be there. Okay. For first PUC, I've already done all that. For second PUC, I'll do a marathon soon. Okay. Good evening, Harshavardhan. Yeah. So are you all fully ready? Okay. Ready to solve question paper? So this will be just like your midterm paper, but a mock paper. Okay. So this paper will have options, but in today's class, I'll solve all the options. Okay. Okay. Yes, Arya, I will take a marathon. Day after tomorrow, I'll take a marathon. Okay. So tell all your friends to be there in class. You can solve your doubts live if you join live during the marathon. Okay. So this is the question paper. So this question paper, I've just, typed it out. Okay. So that you can also solve with me. Okay. So let's start with MCQs. Students, my audio, video, everything is good, right? Can we start? Can I have a confirmation from all of you? All good? Okay. I want you to put answers in the chat, okay? So all those who put answers quickly will get shout outs from me. Yeah? Okay, question number 1. Which of the following statements about the properties of electric charge is incorrect? Okay. Charge is conserved, additive, like charges attract, unlike charges repel, charge is quantized. Which is the answer? Quickly. A, B, C, or D? A, B, C, or D? Quickly get me some answers. Superb. It is option C. Very good. Next question. Okay. Yes, very good, Arya, very good. Match the physical quantities in the first column with the units in second column. Very good, Danush. Identify the correct match. Very good. So that's electric field, electric flux, electrostatic force. I'll just show you this in here so you can see them properly. Yeah, here. Question number 2. Question number 2. Match the physical quantities in column 1 to their units. Okay. So what is the unit of electric field? What is the unit of electric field? Electric field is newtons per coulomb. Yeah. Okay, good. I don't see any answers. Is the chat slow or I don't see answers? What's happening? Okay. Electric flux is Newton Coulomb inverse and electric force is B. So which option is that? 3. B is option C. Right? Are you all getting C? Okay, I got so many C's in the chat. Yasin, Kishan, Arya, Danush. Okay. Yes, very good, very good. Okay. Next question. Shape of equipotential surface in uniform electric field will be. Shape of an equipotential surface in uniform electric field will be. What is the answer to question number 3? It won't be spherical, it won't be random, it won't be circular. So the correct answer will be equidistant planes normal to the electric field. Super. Question number 4. Two conducting spheres A and B of radii A and B respectively are at the same potential. The ratio of their charge densities. The ratio of the charge densities of A and B. What is the answer? The ratio of charge densities of A and B. It is A by B. Yes. Okay, now there are questions I think I can do from here itself. Question number 5. The average thermal velocity of the electrons in a conductor is 0. Statement number 2. Direction of motion of electrons are randomly oriented. What is the answer? Thermal velocity of the electrons in a conductor is 0. Is it 0? Tell me, quickly. Both are correct, no? Yeah, both are correct. And it is the correct explanation. So answer will be A. Option A. Do you all agree? Super. Next, question number 6. In case of insulators, as temperature decreases, its resistivity. Yeah, quickly. Is the chat slow or I don't see any answers? What's happening? Superb. All those who got it right, 6B increases. Very good. Magnetic force is 0 when a proton moves at right angles to a uniform magnetic field. An alpha enters uniform magnetic field at 45 degree. An electron moves parallel to uniform magnetic field. A positron enters a uniform magnetic field at 30 degree. What is the answer? Yes. See, there's no magnetic field when an electron moves parallel to the uniform magnetic field. Next question, all of you will answer, I'm very sure. The torque on a current loop of magnetic moment M placed in a magnetic field B is obviously M cross B. Yeah, option A. Next question. When an electric current is passed through a solenoid, it behaves as a. When an electric current is passed through a solenoid, it behaves as a bar magnet. Harihar Kumar, good evening. The magnetic susceptibility of an ideal diamagnetic substance is. Question number 10. Question number 10. Yeah, it's diamagnetic, so it is C minus 1. The direction of induced EMF is given by. For motor rule and all, we use Fleming's rules. Fleming's right hand, left hand and all that. So here this will be Lenz's law. Okay. Weber is the unit of magnetic flux density, capacitance or electrical conductance. Which one is Weber? Weber is magnetic flux. Yeah. The peak voltage of an AC source is equal to. V peak is equal to. Arya is getting a lot of correct answers. Yes, Falco Gamer, very good. Option A, magnetic flux. Good, Falco Gamer. Good, Bhuven. Good, Arya. Good, Yasin. Danush. Very good. You're all doing really well. Superb. Okay. This is option A. Option D. Some say option A. It's option D. Okay. Good. Who said option D? Falco Gamer. Very good. Option D. Transformers used to Convert AC to DC, convert DC to AC, obtain desired AC voltage, obtain desired DC voltage. What is the answer? Obviously, it's for AC. It's the transformers are used in your house, near power stations, near your house, and all that. Your house gets AC. So it's obtain desired AC voltage. Okay. Question number 15. Arrange the following electromagnetic waves in increasing order of their wavelength. So which one has the highest wavelength? Increasing order of their wavelength. So it's first gamma, yeah. Then you have X-ray, 3-1. 3-1 is option A. Okay. And then you have visible and then radio waves. Yeah. Okay. Okay. Ma'am is lagging bit. Is it lagging? D. I think you're telling me. Which answer are you people selling me? Which is D? Am I lagging or increasing order of wavelength? So radio has the highest wavelengths. Radio. See, if this is the spectrum, then you have radio is here. Then this micro is not there in the option. Infrared is not there. Visible will be next. And then X-ray will be there. Then gamma ray will be there. This is increasing order of wavelength, right? No lag, ma'am. Everything is proper. Now proper. Okay. Okay. Now proper. Yeah. Okay. So increasing order of wavelength. So which one should come first? So 2, 4, 1, 3. 2, 4, 1, 3. So answer is option B. Yeah. Did you all get B? B? Is it B? Are you all getting B? Okay. I don't. Okay. Next, fill in the blanks. Fill in the blanks. You can choose the option and let me know the answer. First question. On reducing voltage, option B is correct, ma'am. Okay, super. Yeah, so we're on the same page. On reducing voltage across a capacitor, its capacitance, what happens to its capacitance? On reducing voltage, capacitance remains constant. Yeah. Okay. The direction of current density in a conductor is. The direction of current density in a conductor is which option? Remains constant. Okay, good, Alina. Yes. Is opposite. Okay. Good, Bhuben. Okay, the resistance of an ideal ammeter is, for an ideal ammeter, an ammeter should detect current. So how much should the resistance of an ideal ammeter be? Zero. It shouldn't have any resistance. What is resistance? Opposition to the flow of current. Okay. Next question. Dash to the direction of drift velocity of free electrons is net magnetic moment per unit volume. What is the answer? Obviously. Magnetization? Yeah. Magnetization. Next question. In electromagnetic waves, electric and magnetic fields are perpendicular. Perpendicular to each other. Opposite 0, 0 remains the same. Good, good, good. 19 opposite. 19 is opposite. 17 is opposite. Yes, good. Magnetization, perpendicular. Okay, so many answers. Very good. Falco, Arya, Sanat, Alina. Yeah, good, good. Now we look at 2 mark questions. Yeah, we finished MCQs, we finished fill in the blanks. Next 2 mark questions. See, in the actual question paper, you don't have to answer all. Okay, but here I've, answered all. First question. First question. When does torque acting on an electric dipole in a uniform electric field be maximum and minimum? Yeah, when is it maximum and minimum? So what is it? See, torque is maximum and minimum. It all depends on the angle. If the angle is 90 degree, then the dipole is perpendicular. Yeah, torque is minimum when it is 0 degree. See, if you have something, if you have, a dipole. Okay, imagine this is the dipole in an electric field. If it's along the electric field, then there's no force. It doesn't have any force. So torque will be minimum. But if it's like this, an electric field is like this, then the electric field produces a force making the torque rotate like this. So when it's 90 degrees, it is going to be maximum. Yes, Arya, I'll send this PDF. It will be there after the class. You can just go to the description and get the link. Okay, next question. Calculate the electrostatic potential energy by positive charge of 10 microcoulomb at a point where electric potential is 2 volts. Yeah. So charge is given, Q is given, V is given. How will you find potential energy? Just by multiplying Q times V. Okay. So U is equal to Q times V. If you simply multiply, you will get the answer. One thing you need to know is 10 microcoulomb is 10 into 10 raised to minus 6 coulomb. That into 2 will give you the answer. Next question. Define current sensitivity of the galvanometer. Hi Guru Raj, welcome to the lesson. Define current sensitivity of the galvanometer. How can it be increased? How can it be increased? How can it be increased? See, current sensitivity is basically how much your galvanometer deflects. Okay? So every time there is current passing through it, how much the galvanometer deflects. Yeah? That is current sensitivity. Now, it can be increased by increasing the number of turns or the area, the strength of the magnetic field, and by decreasing the torsional constant of the spring. Okay, Arya, all the best. No, it won't be Preksha. It will be different because you have it on different dates, right? But more or less, questions will be more or less similar. Mention any 2 properties of magnetic field lines. What is the first one? Magnetic field lines form closed loops and they always start from the north pole and they always go into the south pole. No 2 magnetic field lines intersect. Yeah. So if this is a magnet, magnetic field lines are always like this. This is north, this is south. They go from the north to the south. So 2 magnetic field lines won't intersect. They'll form individual loops. Okay. Next question. State Ampere's circuital law. What does Ampere's circuital law state that? It states that Ampere's circuital law states that, yeah, Ampere's circuital law states that the line integral of magnetic field B around any closed path is equal to mu naught times the total current I naught enclosed by the path. Okay? So mathematically, what is it? Integral of B dot dl is mu I. Yeah? By now, your teachers might have made you by heart this formula, right? The line integral of magnetic field around is equal to mu 0 times the total current enclosed. Okay. Next question. What is electrical resonance? Give the expression for resonant frequency in an AC circuit of an LCR and series. What is electrical resonance? Electrical resonance is when the inductive reactance XL is equal to capacitive reactance XC. Okay, so resonance is when XL is equal to XC. Hence, maximum current. Okay? And the expression for resonant frequency is F naught is equal to 1 by 2 pi square root of LC. Okay? Yeah? So these are all 2 markers. You need not attempt all of them. You will have options. Okay? But I am just, answering all of them because many of you have studied many different chapters and skipped many different chapters, right? Yeah? So from question number 21 to 28, you just have to answer any 5. Okay? These are all 2 markers. Next question. Write the expression for displacement current and explain the terms. What is the expression for displacement current? ID is equal to epsilon naught d phi E by dt. Yeah? Displacement current is d phi E by dt. ID is the displacement current, epsilon naught is permittivity of free space, and d phi by dE is the rate of change of electric flux. Okay, the question clearly says explain the terms. So this is important. You have to write down what each term is. Very important. Okay? Okay. Next question. Write any 2 applications of microwaves. One thing, microwave is used in microwave ovens to cook food. Yeah? It's also used in radar systems for navigation, for weather forecasting, and all of that. Okay. Now from question number 29. From question number 29, it's 5 times 3, which is 15, which means you have to answer 5 questions for 3 marks. Okay? So this is from question number 29 to 36. Question number 29 to 36. Yeah? So you'll have 7 questions, out of which you need to answer 5. So 3 you can skip. Alright? Okay. So let's look at the first question. Obtain an expression for potential energy of a system of 2-point charges in the absence of an electric field. Okay? So if you have 2-point charges, Q1 and Q2, they're separated by a distance R, then potential energy is given by 1 by 4 pi epsilon 0, Q1, Q2 by R. Okay? Yeah? It's given by 1 by 4 pi epsilon 0, Q1, Q2 by R, where Q1 and Q2 are the charges separated by a distance R. Epsilon naught is the permittivity of free space. Okay, next question. Write the expression for electrical resistivity of the conductor in terms of resistance. So resistivity is rho. In terms of resistance is rho is equal to R A by L. This is from the equation R is equal to rho L by A. Some of you might have learned it this way. So when you take it to the other side, it becomes rho is equal to R A by L. And also Write the SI unit of resistivity. What is the SI unit of resistivity? I'll tell you how to derive it. SI unit of resistance is O. SI unit of area is meter square. SI unit of length is meter. So this will cancel. What remains? Ohm meter. Okay. So that's the SI unit of resistivity. Ohm meter. Okay. Next question. State Kirchhoff's junction rule and loop rule. Which rule of Kirchhoff's signifies conservation of energy? Okay. So what does junction rule say? Junction rule says that the total current entering a junction is equal to the total current leaving a junction. Yeah. So if you have so many currents, okay. Let's say, okay, let me draw a better diagram. Let me just draw a better diagram. Yeah. So this is going in, coming out. Okay. I1, I2, I3, I4. So I1 and I2 are coming in. So I1 plus I2 is equal to I3 plus I4. Okay. That's junction rule. Now what does loop rule say? Loop rule. Oh my god, my tongue. Loop rule says that the algebraic sum of all the potential difference in any closed loop is 0. Yeah. So if you take a closed loop with a resistance and a battery and all that, the total potential difference is 0. And loop rule signifies conservation of energy and the other one signifies conservation of charge. Okay, next question. State and explain Biot-Savart's law, write its vector form. What does Biot-Savart's law state that? If you have a current carrying one, oh my god, if you have a current carrying conductor, okay, then you take a point P, the magnetic field at that point P will be due to a small current element IDL, yeah, okay, and it's going to be proportional to current, length, and sine of the angle between them. So that is how you get this in vector form. Okay, next question. A circular copper coil of radius 6.284 has 20 turns. If a current of 2 amps is passed through this, find the magnitude of magnetic moment of the coil. So magnetic moment, we already know what is the formula. It's NIA. And what is A? N of N is the number of turns into I. Area of a coil is pi r square. So if you do Ni pi r square, you will get the answer. Okay? Yes? Okay. Next question. Give any 3 differences between diamagnetic and paramagnetic substance. I put it in a table so that you can, easily understand. So a diamagnetic substance is a substance opposite to the applied field. Not a substance, its magnetization is opposite to the applied field. So if you have magnetic field coming this way, its magnetization will be in the opposite direction. But for a para, its magnetization will be along the applied field. Okay? Now what about susceptibility? For diamagnetic, susceptibility is negative and small. For para, the susceptibility is positive and small. Example of diamagnetic is copper. For para, it's sodium, aluminium, and all that. Okay? So, now I think you can see it properly. Is my head covering it? Ma'am, PDF. PDF I'll give. Okay. Obtain an expression for the motional EMF in a rod moving in a magnetic field. Yeah. The motional EMF generated when a rod of length L moves with velocity V to uniform magnetic field B is equals EMF equals BLV. Mention any 3 factors affecting energy loss in a transformer. What are the different factors affecting? Copper losses, iron losses due to hysteresis, eddy currents, flux leakage. Okay, all of these are factors affecting losses. Okay, next we will look at the 5-mark questions. Okay, so for 5 marks, you need to attempt 3 questions. Okay, so this is 3 questions for 5 marks. So from number 37 to 41. Okay. Yeah, out of these questions, you need to attempt 3 questions for your final exam. That is how you should be attempting it. Okay. How much paper discusses? See, Bhuvan, I'm doing a full question paper. Okay. All questions I'm discussing. Okay. Question. 5-mark question. Derive an expression for electric field at a point due to an infinitely long, thin, uniformly charged straight wire using Gauss law. Okay. So, first thing for these kinds of derivations, diagram is very important. Okay. Students, without diagram, if you do the derivation, you will not get marks. Okay. So, please don't by heart the derivation and then don't draw diagram and go tell your teacher, ma'am, I have written everything and not gotten marks. No, you have to draw a diagram. It's very, very important. Okay. Okay. So, first thing, let's look at the diagram. Okay. Let's look at the diagram. So for the diagram, you have a wire. Yeah. It's a long uniform wire. Yes. And it's charged. So it's all positive. Okay. So how will you draw a Gaussian surface along a wire? See, a Gaussian surface is a surface that's equally distributed around a charge. So if you have a wire of charge, the Gaussian around it will be cylindrical. Okay. See, if you have a point charge, the Gaussian around it will be spherical. If you have a line of charge, the Gaussian around it will be cylindrical. So around the line of charge, you draw a cylinder. Okay. And L is the length of the cylinder. Yeah. R is the radius of the cylinder. Okay. R radius of cylinder. And there is electric field also. Okay. Now let's do the derivation. First thing, integral of E dot dA is equal to Q by epsilon naught. This rule we already learned. Which law is this? The famous Gauss law. So students, when you write a derivation, small introduction is important, then diagram, then derivation. Like how I have done it here. So for introduction, what will you write? You will write this. Consider a long straight wire with uniform linear charge lambda. Take a point at a perpendicular distance r from the wire. Draw a Gaussian cylindrical surface of r and length L around the wire. By symmetry, E at every point on the curved surface is radial and constant in magnitude. By Gauss law, phi of surface is equal to E dot dA, which is Q enclosed by epsilon. Okay. So you have to write an introduction like this. And then let's do the next step. Now, what is the area of a cylinder? It is 2 pi RL. So instead of dA, you'll write 2 pi RL. And what's the charge? It is lambda L. Okay. So charge Q is lambda L. Yeah. And then you rearrange, you will get this answer. E is equal to lambda divided by 2 pi epsilon naught R. Alright? Okay. Next question. Derive an expression for effective capacitance of two capacitors connected in series. mention any two characteristics of equipotential surface. Okay. So expression for effective capacitance of two capacitors in series. So the image will be something like this. Yeah. So there will be two capacitors in series. Okay. Now, if you have two capacitors, for this also diagram, very important. If you have two capacitors in series, let C1 be the capacitance of the first one, C2 be the capacitance of the second one. Okay. C1 be the capacitance of the first one, C2 be the capacitance of the second. The same charge Q flows through both. Yeah. The same charge. But let's say capacitance C1 has a voltage of V1 and this has a voltage of V2. Okay. So now total voltage is what? V1 plus V2. Okay. Total voltage is V1 plus V2. So what is charge V? We already know. Q is equal to CV. We already know. So Q will be for the first capacitance, it will be Q will be CV1. For the second one, it will be C2V2. But both have the charge Q. So you can say C1V1 equals C2V2. Yeah. Now this I can also rearrange and write saying that V1 equals Q by C and V2 is equal to Q by C2. Yeah. This one V1 equals Q by C1, V2 equals Q by C2. So V is equal to V1 plus V2. So this is basically Q by C1 plus Q by C2. Now if you take Q outside, this will become 1 by C1 plus 1 by C2. Now what about this part? So V by Q is C. Yeah, no, 1 by C. So instead of this much, I can write wait. I shouldn't have erased everything. Yeah. Now, V by Q is equal to 1 by C1 plus 1 by C2. And this V by Q is what? 1 by C equivalent. Okay. So that will be the answer. Okay. So that's first part. Second part, mention any two characteristics of equipotential surface. No work is done in moving the charge because the potential is same. So you don't have to do any work. Next, equipotential surfaces are always perpendicular to electric field. Yeah. If this is the surface, it's perpendicular to electric field. Okay. Next question. Derive an expression for effective EMF and effective internal resistance of two cells connected in parallel. Okay. Again, figure very important. So you have this is the first cell, second cell, they are connected in parallel. Okay. So if there's a current I coming, current comes, it goes here, 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 and then goes here. Okay. Was that clear? Should I draw it once again? See, this is one cell, another cell. Okay, so current comes, goes this way, goes this way. From here also output. This is how it is. Okay, so this is like equivalent to this, equivalent to a single cell, two cells in parallel. Okay, diagram is important. Now, let's do the derivation. So let's say the two cells have EMF E1 and E2. Okay. And let's say they have resistance R1 and R2. Okay. So the two cells have EMF E1 and E2, resistance R1 and R2. And they're connected in parallel. So in parallel circuit, current is different on both halves. So current on the first half of the triangle and second half of the triangle will be different. So total current will be I will be equal to I1 plus I2. Okay. Now, from Kirchhoff's law, we already know that um, the total voltage should be the same. Yeah. So, if you have first, the voltage should be E1 minus V by R1 plus E2 minus V by R2 should be equal to the total voltage divided by total resistance. Kirchhoff's law. Yeah. Now, from this, what is this? This is equal to E. Okay. Yeah. Sorry, I. What am I writing? So, total EMF will be E will be equal to E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. And total resistance will be what? 1 by R will be equal to 1 by R1 plus 1 by R2. This when you cross multiply, you will get R1 plus R2 by R1 R2. When you take the reciprocal, you will get R is equal to R1 R2 divided by R1 plus R2. Okay. Next question. Question number 40. Arrive at an expression for the force between parallel conductors carrying current and hence define amps. So there also diagram is important. Diagram. Second. Yeah. So you have two parallel wires. Okay. Two parallel conducting wires and they have they have force between them, so they have current passing in the same direction. Yeah, so this is I1, this is I2. So both of them have magnetic fields. So magnetic field is given by mu 0 I into 2 pi d. Okay, so what will the force be? I2 LB1, which is I2. I just substituted B1. This is B1, I substituted that here, and F by L is given by this. So this is the force on the parallel wire. So from this we can say that 1 ampere is that constant current which, if maintained in two straight parallel conductors of infinite length and 1 meter apart in vacuum, produces a force of 2 times 10 raised to minus 7 newtons per meter length of each conductor. So this definition, you're going to get it from this derivation. Okay, so this is the definition for amps or 1 ampere. Okay, yeah. Next question is the last 5-mark question. State and explain Lenz's law of electromagnetic induction. B is what is AC generator? Mention its principle. So Lenz's law states that the direction of induced EMF of or current is that it opposes the cause that produces it. Yeah. So if you have a coil and you move a magnet into the coil, okay, it's the magnet and you move it. This is the coil and you move a magnet into the coil. The magnet tries to oppose the motion. So the direction of induced EMF tries to oppose the cause that produces it. Okay. If the magnetic flux through coil increases, the induced current creates a field to decrease the flux and the opposite. Okay. So there's a figure here. This figure you can draw if you want to. It's not compulsory. Okay. You can draw this figure if you want. One. Okay, let's put it like this. Five marks question video is not in the playlist. See, 5 marks I've only done for first PUC, not for second PUC. Okay. Okay. Now, AC generator is a device that converts mechanical energy into alternating electrical energy. What is an AC generator? Basically, a coil moves and that movement is converted into electricity. And the principle is principle of electromagnetic induction. Okay? Induced EMF is produced when you have two magnets, you have a coil between the magnets. When the coil rotates, yeah, that rotation cuts the magnetic field and that produces a current which is used to do things like light a bulb or whatever you want. Okay. Okay, so that those are the 5 markers. Now let's do numericals, right? So how many numericals will you have? You have 4 numericals, out of which you have to attempt only 2. So 2 options you have. 4 questions. Out of that, you can attempt only 2 questions. Okay? Yes. Yes. No. Hi, Aradhya. Okay. So 2 point charges plus 5 coulomb and minus 10 coulomb are placed at the vertices B and C respectively of an equilateral triangle ABC. So this is a triangle. Okay. This is the triangle ABC. Okay. 10 centimeter, 10 centimeter, 10 centimeter. So there's 2 charges. I think I should put the alphabets in a different order so it's easy for you to understand. So if this is A, this is B, and this is C. Okay. So this is plus 5 coulomb and this is minus 10 coulombs. Yeah. Calculate the magnitude and direction of resultant electric field at the vertex A. We have to calculate the resultant at A. Okay. Yeah. Okay. We have to calculate the resultant at A. How will you do that? So, what we'll do first is we will find out the electric field, okay, E1 and E2. All right. So, the electric field at point at vertices B and vertices C. So, let's say E1 is the electric field from B and E2 is the electric field from C. Okay. So, how will you find E1? 1 by 4 pi epsilon 0 Q by the radius, I mean the distance square. Here it's just put as a square. So 1 by 4 pi epsilon 0 is how much? 9 into 10 raised to 9 times. What is the charge? 5 divided by the distance is 10 centimeters, 0.1 meters. So 5 by 0.1. So the answer is 4.5 times 10 raised to 12 newtons per coulomb. Okay. Now for E2, what will you write? 9 into 10 raised to 9 times minus 10 divided by 0.1 square, which is equal to minus 9 into 10 raised to 12 newtons per coulomb. Okay? Yes. Is this much clear? I found out the electric field at E1 and E2, which is at point B and point C. Okay? I'm not getting any response. Hmm. Okay, ma'am. Okay, ma'am. Okay, just a second, students. A small technical my board. 1 second. Fine now. Hmm? Are you all getting E1 and E2? Yeah. So to find the resultant, what will you do? You have to take the vector sum. So you have E1 and E2. How will you find out the vector sum? If you do the vector sum, you will get 7.79 times 10 raised to 12 newtons per coulomb. Okay. And it will be downwards from A. So basically it will be along the minus y-axis. Not the positive y-axis, but along the negative y-axis. Ma'am, okay, done, ma'am. Hello, E2. This hello, E2. Okay. Okay. In a circular parallel plate capacitor, the radius of each plate is 5 centimeter. Okay. A circular parallel plate capacitor radius is 5 centimeter. They are separated by a distance of 2 meters. Okay, so you have a capacitor and it's separated by 2 millimeters. Okay. Calculate the capacitance of energy stored when it is charged by connecting a battery of 200 volts. Direct substitution. We already know formula is what? C is equal to epsilon naught A by D. Epsilon naught is given in the question 8.85 into 10 raised to minus 12 into area is not given, but you need to calculate with the radius. So it will be pi into 5 centimeters, so 0.05 meters square. So you will get 7.854 into 10 raised to minus 3 divided by the distance is 2 millimeters, which is 2 into 10 raised to minus 3 meters. So you will get 3.48. Now the second part of the question also says calculate the energy stored. Energy stored is what? Half CV square. So half into 3.48 into 10 raised to minus 11 into voltage is also given in the question 200. So 200 square. This is a very simple direct question. Okay. Yeah. Chetan ji, are you talking about E2 in this question? Are you talking about E2 or E net? Hmm? See, E net is just vector sum. Okay, that step is not written here. See, E net is basically square root of what? E1 square plus E2 square minus 2E1 E2 cos 60 because it's an equilateral triangle. If you do this, you will get the answer. Yes? Okay. Next question. Question number 44. A copper wire has a resistance of 10 ohm and an area of cross section 1 millimeter square. Okay. So there's a wire. This wire has a resistance of 10 ohms and an area of cross section of 1 millimeter square. Okay. Area of cross section of 1 millimeter square. Okay. A potential difference of 10 volt exists across the wire. Okay. Potential difference is 10 volts. Calculate the drift velocity of the electron if the number density is 8 into 10 raised to 28 electrons. Okay. So formula for drift velocity is what? Vd is equal to I by NAE. You might have learned the formula I is equal to NAEVD. So from that, rearranging, you will get VD is equal to I by NAE. I is given. Where is it given? I mean, I is not given. Okay. So to find out I, what you should do? V is given, R is given. Resistance is 10, voltage is 10. So 10 by 10, Ohm's law. V is equal to IR. Yeah. From the Ohm's law, V is equal to IR. I is equal to V by R, which is 10 by 10, which is 1 amps. Okay. So VD is equal to I by NAE, which is VD is equal to 1 by N is how much? 8 into 10 raised to 28 from the question, the number of electrons, into 1 into 1 into area. Where is the area given in the question? 1 millimeter. So 1 millimeter will be 1 into 10 raised to minus 3 millimeter square. So minus 6 into the charge of 1 electron, which is 1.6 into 10 raised to minus 19. Okay. Yeah. So 8 and 16, if you do, you'll get 128. So 8 into 1.6 will be 12.8. So this will be 1 divided by 12.8 into 10 raised to 28 minus 6 minus 19. And then if you solve it and you do 1 by 12.8, you get the answer. Okay. Some of you might get it as 8. That's also fine. 7.81 is basically 8 itself. Okay, next question. Let's look at the next question. This is the last question here. So this is the last question of the whole question paper. Okay. A resistor of 100 ohm, a pure inductor of L equals 0.5 H, and a capacitor are in a series circuit. Okay. So this is a series circuit with a resistor, inductor, and a capacitor with an AC source. Okay. So resistor is 100 ohm, inductor is 0.5 H, and a capacitor is in series containing an AC source. This is 200 volts, 50 hertz. Current is ahead by voltage. Current is ahead of voltage by 30 degree. Okay. Current is ahead of voltage by 30 degree. So what all are given? I've written that down here. R is 100, L is 0.5, F is 50, V is 200, phi is 30. So current leads voltage, so capacitive. Okay. So if current leads voltage, it means it's capacitive. Okay. So what is the first formula? Omega is equal to 2 pi F. So which is basically 2 into 3.14 or 2 into pi into 50. If you do the math, you will get 314.16. I think you can use a basic calculator, right? So you can easily solve this. Next, XL equals omega L. So omega is 314 into 0.5. So you get 157.08. Okay. Next is tan phi is equal to XC minus XL by R. Okay. What is tan phi? The angle given, it's already given that current is ahead of voltage by 30 degree. So theta will be 30 degree. So tan theta will be equal to XC minus 157.08 by 100. Now tan 30 is how much? 0.57. You can find that from your class table. You will get it as 0.57. Yeah, so 0.57 will be XC minus 157.08 by 100. Rearranging, you will get XC is equal to 0.577 times 100 plus 157. So the answer will be 215.78. These numbers I've not solved here because you can use a calculator. So you don't have to know mental math or anything like that. But when you prepare for your competitive exams, then it becomes important. Okay? Yes? Okay. Now, there's also one more thing. You have to find out the value of capacitance. So you have XC now. You have omega. So how will you find out the value of capacitance? Very easy. Capacitance is 1 by omega XC. That's all. So this will be 1 divided by 314.16 into 215.78. So this is basically 1.48 into 10 raised to minus 5 farad. So I shift the decimal ones here. So I can write it as 14.8 microfarad. Okay? Yeah? Is this fine? So we've solved a midterm paper. Okay, you might, no, I've not solved it that fast. It's just that I had already typed out the answers. So I didn't have to waste time writing it. So your paper will be for 3 hours. So you will get enough and more time to solve the paper. Okay. A lot of time will be there. So concentrate and answer all the questions. Yeah. I will share this PDF with you. So if you want to access this PDF, please join the Vedantu Karnataka Telegram channel. Okay. The link will be there in the description. So if you join that, you can get the PDF. Okay. Yeah. Okay, Bhuvan. Okay, Sagar. Yeah. Okay. So I'll see you all with another video. I've already made a video on, important derivations and all that. And I'm going to do a video tomorrow on, tricks and tips to score 80 on 80. So make sure you watch that also. Then I'll tell you on how to effectively solve these papers. Okay. So I hope you're all doing well, studying well. All the best. Keep rocking. Vedantu Karnataka is there to help you at all point. And even between your midsem, please don't forget to write the MBSAT scholarship test. Yeah. It's a wonderful opportunity, students. If I had a kid, I would have definitely made him or her write. Okay. Right now, all of you are my kids. So I want all of you to write. Don't miss out on that fantastic opportunity. Okay. So until we see next time, bye bye.